not there in the database. So people is a common term are using it, but again, this I'll repeat that for what is the database is something. Whatever their understanding, your understanding is something is true. It is like organizing the data of data collection. We store and access electronically. Okay, something like where we maintain like warehouse management, where we'll store all the data stored in that warehouse, right? The same way, this electronical warehouse management. So that the data is stored at somewhere, on the electronically, and it's not the physical, it's electronically, and where it will read it, or it will provide the access, and that is it will provide the access whenever it's required. Store and provide the access. Okay, it allows for efficient data storage, retrieval, updating, and management. So data represents as below image, like always database represents here. If you see in any of the system diagrams, or system design or architecture flows, you can see the database is like this. So that you need to understand. Okay. The second one is about DBMS, where you also heard about database management system. Database management system. Okay, so this is just a database where we are seeing, and the about is like how database management happen. So that we can talk about DBMS. Okay, DBMS is a software actually. Okay, this is a software that interact with end users, applications, and the database itself to capture and analyze the data. Okay, DBMS is a software and system, where it interacts the users, applications, and database itself to capture and analyze the data. So what are the principles of the database, characteristics of the database? Okay. So this is the first and foremost is provide a systematic way to create and retrieve, update, and manage data. Okay. Okay, it could be anywhere, like just like not somewhere, it will sort anywhere we can keep the files. For example, we are keeping the files into a file system, right? Whenever in Windows laptop or Windows desktop, if you want to prepare one document or PPT, any kind of thing, that what you do, the first step is like you can save it one name in one folder, right? Why you are creating a folder and keep it there? So that you want to organize it very well, right? And also whenever you require, you can go to that path and you can open it. If you forget the path, you will search it in Windows Explorer, right? So the result is kind of a DBMS example I'm talking about. Okay, one of the simplest DBMS where people will understand. So there also we are storing file is a kind of, if you consider as a data, we are storing that in a file system somewhere, C drive, D drive, or anywhere in the computer. Okay, and can use the various data models, hierarchy, network, etc. Hierarchical network, etc. Maybe it can be stored in the same system, or maybe in the different systems as well. Okay, network. Maybe if you have the LAN connectivity, something like there will be a master computer, or master machine there, where we can upload that into a master. And if you want to, if you're not sure that you will carry the laptop, but I want to store this in a cloud, you can store this in a cloud as well. So for that too, it required a network to upload that file, into another machine, right? If you want to store the file into your local machine, network is not required. Okay. So it doesn't necessarily enforce relationships between the data. So when I say relationships here, right, this we need to understand more. Okay, as I mentioned yesterday, student, department, and college. So what are the relationship between these three? Is a student is associate to college, and also student is associate to department, right? Because when his name, like when his profile view, you can see that, okay, student is so and so college, and also is and in particular department, right? So there is a relation between, because if you go to the departments itself, like you can get in the departments and how many are students. So the data of the students are can store in a department table. At the same time, some of the information that will be, there in the college table, not the some of the data, like some key data. So if you want to go to the students, particularly go to the college table, and can also fetch some of the information, key information about the student, and go to the department. There also you can get some of the information, more information about the student. So there is a relation between student and department. Like multiple students can map to one department, whereas multiple departments cannot be mapped to student, right? So that's the relation. So one department may have multiple students. The mapping, like one department having multiple students, and multiple departments are mapping to one college. So these all are talking about the relationships. Same as like in our family, how we are. Okay, he's my brother, and okay, she is my sister, he's my father, and she's my mom. Okay, he's my grandfather, she's my grandmother, and relationships between, right, grandmother to grandson, grandfather to granddaughter. So there will be relationships between, so that where easily we can match it. Whoever is available, and which parameter if we want to consider, especially in terms of data analytics. Okay, for data, if you want to retrieve and get that kind of a trend, or data metrics, if you want, just like these relationships are very much useful. Okay, so here when I say DBMS, they mention like not, if it is there that is fine, but you're not enforcing here. Okay, between data, typically used for smaller and simpler applications, because that DBMS is not enforcing relational database management. So it may be like it is used for smaller applications, or having only one key value pair kind of stuff, just only one person, and it's having the key value pair, some kind of a where you can maintain caching, where we can store the value into a map, right? So so for the simple kind of a data bases that we're using, for example, in file system, I can say file system, where what is the file name is the key, right? Key, so the data associated, and what is the file name for that is for particular folder, right? That folder is associated where it's stored. That's simple. So all will get stored with the name. What are they giving? The name should be unique. That's all. Nothing else more than that, right? So examples of DBMS I've given here. The best example and easy understand is a file system. Technically, it is a simple DBMS. Some kind of XML databases also. If you want to So that data into XMLs, right? We can do the XML databases. And object-oriented databases also we do have it. This will simply store that object into a table. And key value stores like Redis. This is the best example. As I mentioned, Redis is one kind of a caching system. Okay, where the caching is very required. If you guys are not knowing, okay, this the temporarily will read the data and will keep it, in store. Particularly when you say during the peak time e-commerce applications also, if you are retrieving the data again and again, right? It won't pull the data from the database. It's every time that will get cache over network or in our physical mobile, at somewhere or or laptop. So it could be different. It could be a browser cache or application cache, something. So browser also will maintain some kind of a caching storage where it will store some of the uh, commonly using data, commonly retrieving the data. So that's a key value stores like Redis. So these are the best examples for DBMS. Then we can go to the RDBMS. This is like relational database management system again. Okay, relational database management system. So the difference like between the DBMS and RDBMS is, okay, just as name suggests, is like R, relational. So the above four, like 1, 2, 3, 4, right? You don't need to maintain, not enforcing the relationship, but in the relational database management we are enforcing. Saying that like it's a, for example, in DBMS, like where the files are small, like you can keep it. In the worst case, if you want to keep it something, right, file, we can keep it, even forget it also, we can search it if it is small. Assume like there are 1 or 2 million records, 1 or 2 million files are there in that. If you forget the path, or if you don't know where it is getting stored, imagine like if you want to search it where the file is, then if you select that like my computer, and that the when you search, like how that will go, it will take 10 to 15 minutes to search one file, right? Because it has to be indexing and search it. So if you search it like in a kind of a files 5 to 10 times, so what do you say, like you get frustrated, right? That like I keep forgetting this stuff, and I have only one, some common name, I don't know exact name, where I don't know where I store the part. How will you remember where you store this information? How organized you do? Sometimes you lose, right? So yes, for huge data, and if there is no relationship, and it will be more difficult to retrieve the data wherever, finding, mainly finding. If you know the path, you can go there and can get it easily, but finding the path itself is a challenging activity in database management systems. If it is a complex kind of data, that's why like we need to have it only simple kind of data, or like the type is a key value kind of stuff. Okay, key value kind of stuff. We don't only that file name in a like cache management system, right? It organizes very well. It won't have multiple combinations of key and like sub keys. We don't have it, only one key, that all, and value, that's all. We store only this part, and then it'll retrieve. But if you have multiple combinations, as I mentioned, for a family, okay, who is the elder brother and who is the elder sister, younger brother and younger sister, okay, first, eldest brother is just elder brother just before me, our second elder brother, our second younger brother, there will be relationships, right? The names, if you name it. So if you have that the complex uh, you know data, and you need it any point in time, anyone, maybe I want like in a second elder brother details, you know, when we all, you know, when we all go to the vacation, or when we have, you know, third younger brother details when on the uh, second elder brother's marriage. So these are the typical relationships and also, you know, criteria to get the data. That time it is, you know, it is most difficult, you know, in the DBMS. So that's what, like, you know, RDBMS is evaluated. Always I can say, right, all the softwares are evolving based on the, you know, solving the real-time problems. Okay, so real world problems always, you know, they're still there, that's what, like, evaluation software, how our livelihood, our lifestyles are getting changed. Based on that, like, software is also getting evolved, the technology is also coming along with us. Okay, people, we are thinking like, you know, we are going, technology is growing and we are also getting changed. No, we are getting changes, then technology is also evolving, and technology also taking some kind of a, you know, advantage on our lifestyles. So anyway, that's the relational database management system that we are talking about, the characteristics that we can discuss about it. Okay, so RDBS more advantage of DBMS, you know, that stores data in a tables, relations, and uses a SQL. This is the most waiting word for us, right? SQL for data manipulations. Okay, so this can be used in on RDBMS. Okay, not the DBMS, because this is defined or designed or evaluated. So once RDBMS come into picture, so you need to understand is, like, you know, where we are working. This is SQL is on RDBMS, right? So the characteristics of RDBMS we can discuss now. The data stores in a table with rows and columns. You see that this as the table. Okay, the tables and columns we need to store it so that, like, we can get it. Okay, for example, if the student may have one student ID or roll number. Okay, his name, his department, his class, you know, and his address. So these all the, you know, rows and columns, is one row for one student, and these are the columns, I can say. But the columns like enrollment, name, college, department, class, and address. Because with these 6 columns, right, we can get the multiple, you know, various flavor of, or, you know, various trend of the data. Okay, if you take that particular student name, okay, for example, with Rama, how many names start with, okay, Rama in a class, right? Okay, all the first names are last names, okay, they which are mapped with Rama, list out there, right? That is one of the criteria. Okay, and that we can get it. And what are the addresses, right? When you say, like, who are there in the location, for example, in Hyderabad city, if you select, what are, you know, the students, who are the students are coming from Hyderabad, are staying in Hyderabad, who are coming to our college, right? So that you can filter, and who are there in, like, you can have multiple combination also, right? Who are coming from Hyderabad and who are coming from, you know, from ITech city or from Gachibowli, okay, or who are coming from Telangana state, okay, who are coming from Andhra states. So these are, like, you know, can have, by defining the columns, right? So we can have more flexibility to get the different flavors of data whenever we need it for data metrics or analytics, right? So That's why like RDBMS is very helpful in these criteria for to solve the more real-time problems. Okay, tables can be related through keys, primary or foreign keys. Okay, this will just talk about once you are dig into deeper. Just for now, you can understand these are to identify particular particular row or particular student. If when I say, assume like it's a kind of enrollment ID which is unique, right? For enrollment ID cannot be given to other, so it is tagging only one student, right? The same way foreign key and foreign primary key and foreign keys. Follow ACID properties. Okay, yesterday I just highlighted atomicity, okay, consistency, isolation, and durability. Okay, this we can talk discuss about in separate in upcoming discussions, but these are the complete rules where there is a transaction management separate but yes, when I repeat that particularly if you want to transfer amount from one account to another account, so transaction success is nothing but amount is getting debited from the from account and it will be credited to the beneficiary account, right? Sender account and beneficiary account. Sender account should be debited, so current balance is nothing but total balance minus transferred amount, and the sender recipient or beneficiary account current balance is total balance plus okay whatever the amount is transferred. So that is properly managing that. If any network failure between happen, any issue happen, it should revert the primary account number, right? Sender account number. So there are certain rules, okay? So they strictly follow this one. That is the ACID, we can say, rules. You can remember. So this RDBMS strictly follows this ACID rules properties. This you need to remember. And use a structured query language SQL. Use a structured query languages. This is the most important part. That the purpose that we are joined here to learn, right? So SQL is going to work upon the RDBMS. Yeah, support the complex queries and transactions. Yeah, anyway, the queries is nothing but the query languages, right? Thus we can discuss about the transaction also, how ACID properties works on the transaction. This and all we can discuss. But yeah, characteristics like support the complex queries and transactions. So this is the purpose only like RDBMS evolved for the complex as we discussed about it. Okay. Some of the examples of RDBMS, I think most of people, I think you be aware of. MySQL is open source. PostgreSQL, Oracle database, it's a license. Okay, in the earlier days they have given like some of the free version in very beginning like 2008, 9, not even 9, sorry, 2004 or 5, I think, when we are studying there, pursuing like academics. That point in time it is a free of cost. Later they they given at least some of the portion now they are given the completely enterprised. Now it's a paid version now. But yeah, this is the most popular database which which we all know in the beginning. So yeah, MySQL also similar to this, but yeah, it's open source. Most of the people also are using it. Very like open source projects are using. And Microsoft SQL Server. I think these people also know. Most of the Microsoft people are using Microsoft SQL Server is a database because this come up with Microsoft itself of their own. It's kind of like all RDBP maps. They need to follow all this, into the same characteristics. But they have their own branding and some of the enhancing feature. That's all. But they need to follow the same common characteristics everywhere. Okay. can say key differences between DBMS and RDBMS, I can say. Now you see, um, it's a data structure. Okay, data structure point of view. Various models, hierarchical network, and etc. But RDBMS point of view, tabular structure with um, relation between tables. Okay, data structure point of view that will store only hierarchical stores. Some, for example, if you want to create a folder structure, you will create, right? For example, college name, and the college name will open and create another folder called departments. Departments, and departments, like there is a okay, IT and non-IT. Okay, and non-IT, like where there's admin department, and admin department they'll have all the employees. Okay, and the departments like following the classes, and all the students, like that. So we need to create the hierarchical stuff there, which is organizing. Will, if you know the path, you can dig into it, but like retrieval is more difficult, and also that's why like every the information that will push the database these days to managing it, right? So here is a table structure with relation between tables in RDBMS. And the second category is the data relationships, how the relationships works here. So no inherent relationships here, DBMS, but explicit relationships via keys. Okay. This we can these points we can discuss when we go to the RDBMS as there. Where keys, like I said, a primary key and foreign keys, right? That with that we can get it. Okay. One department is having one department ID always, that and that will not change. One student enroll ID will be there, that cannot be changed, right? That will be tagging. So with that ID or coding, so you can come to know where we need to locate, right? So particular college code, department code, and for example, if you want to maintain the hall tickets, right? For the hall ticket number and location, they'll mention where exactly you are, going to take a exam. Okay, they'll having that code. For example, for this class, for this college, for this department, for this section, they'll generate one common code. So there. Same way like in a locations also, right? So location code, that is. So that's all come with the tables and relationships between. And normalization. When say normalization, the word I think we need to understand more. And that's all like one we need to segregate common data into a separated tables. If you want to keep it all the data in a single, then it will be more difficult, right? Student name, student address. Again, address is saying that like from where, which area, which city, or like where what is the father name, mother name, and which district, which state, and also which department. This and all, if you want to maintain all in a single database, like it will be more difficult to retrieve and organize it. Rather than we can split that data into a separate category, like say city name, father name, mother name, state, and pin code. This and all we can consider as a one address, right? One address table. And department ID, and address table, we can give the one address ID there. Okay. Department also department name. Okay, department head, or department location, about the department information we can split into one table, and this we can generate one ID for one department. Okay, and student also, like having student, basically student name and ID, and basic information with that, which class he is. So with that, right, and the same table will map the address ID and map this department ID. That's all. So that we don't need to have a lot of columns in that. So that we can discuss about. So where we are digging, splitting complex data into an organized manner, So that is called normalization. So that normalization is not supporting the DBMS here, but where it supports explicitly with relationships via keys. That's what I mentioned, right? Address ID is generate one ID for you, and you can have it. Department ID like that. And data redundancy. Data redundancy is a common. Data redundancy is a common, but minimize the through the normalization. Meaning like same thing data redundancy. If you want to maintain single table, right, we need to maybe repeat like student name multiple times, right? So like example of name, if you want to give the data in the PAN card or Aadhaar card, right, you need to give the name and addresses both the places, right? Now these days, like they are saying, like Aadhaar is considering is only one address proof, right? Previously there are multiple address proofs, right? Voter card, ration card, PAN card. Okay, sorry, PAN card Minada, but yeah, and other things, right? Residential proof, all are like an ID cards. This will be the same information, same address will be there. So that is kind of a duplication, right? That is kind of a redundant information. Yeah, that's then the DBMS is a common because where we don't maintain the relations between that, so we need to maintain that common data. But yeah, here we can minimize through the normalization. So where we can split that into a separate table and we can map only tagging, right? So that data redundancy can be achieved, or minimized through normalization. Query language. Okay, it's a proprietary here and but yeah, standard SQL. The proprietary is normal key value pair kind of stuff, minimal information with that we can get it. But here, standard SQL using that query language we can use it exclusively as the RDBMS. Extensively we can use it. Okay, scalability is nothing but scalability is something like where we can increase the data at any point in time, so it won't affect our system. So that is scalability, right? So if there is a huge data comes or kind of stuff, right? Like maintain that into a one. For example, there will be last time happened Kumbh Mela, right? So organize that Kumbh Mela was like more complex, but like they have a lot of systems are arranged there, right, for cleaning the water and cleaning the garbage at their places, and all sanity works are like they will be working for 24/7. There will be some kind of a system to work on that and to quickly, right? So that when the scalability comes, like keep on coming, first day how many people are come, second day people they grow, right? If the crowd is growing, then how to handle that kind of a scalability. Okay, so if the DBMS is very limited, where we cannot bear that kind of stuff because that management is very low. I mean, this is because that is DBMS very limited for the small applications like that. It cannot bear it, right? So then highly scalable RDBMS, because simply that you can increase the space, because as we are already organizing it, right? So easily manage it. So here examples like file systems XML, and for database part of here MySQL, Oracle SQL Server, as I mentioned. So this is already discussed. As it components is rarely uses, and but yeah, is always follows. Distributed supports is a limited and strongly support. Distributed system is like on database these days, like not at one place, right? One location. Maybe like if it is a huge data, something like Amazon or Flipkart, the data is very huge, right? Or the store management that will not be there in one common one single place. There will be data centers we see in Hyderabad also. Amazon data centers are centers are there, right? The data centers will store that data into there. And also, I mean, when I say the clouds are having different locations, the follow the distributed support. Distributed mean like we can distribute. So some of the data you keep it here, some of the data you can keep it there. So if the data usage is low at particular place, that like one other place data is more, then you can transfer from some of the data to here. So that can distribute internally and provide and the access whenever you need it. So that will not be knowing for the users where it is, but it's a common data where it can maintain that like that. Okay. So the practice example data DBMS examples like key value, store Redis, like how it works, set user something and name join and age 30 and email something like this. Okay, and get user this 100, it will get the data like this. So this is a JSON format. Redis, right? So we are using setting here user for 1000 is a key, for 1000 is a student enroll number, and the name is storing like this is in this format. When I say get user 1000, so it will get this data back. That's all. Just a simple key value pair. So RDBMs, right? Like there is a kind of a table structure as I discussed. We can have a deep dive in the next classes. Table users here, and table users and ID. We need to mention like definition itself. We need to define properly which type of it is integer, or string, or boolean kind of stuff. Okay, and the name also we need to define one. Define it's a varchar is of a type. Yes, it's a data types like we can discuss. Email as a varchar. Then once you find this table, we are inserting data in this way. Insert into user values. Okay, 1000, John, 30, and email. And select star from users where ID equal to this. So this is the way of SQL notation. So we will get this value. DBMS will get the value like this. Okay. Yeah, we can discuss more, but yeah, that's how it works. Yeah, here I can also choose like when we need to use RDBMS, when we need to choose DBMS. Okay. So your data is complex relationships, and you need ACID compliance for transactions. Data integrity is critical, and you need to run complex queries. Okay, then RDBMS is the right system, database management system. Example, banking and e-commerce platforms and ERP systems. Okay, so modern applications often using RDBMS for core data and DBMS like Redis. Right, RDBMS for core data if you want to store it, and DBMS is like Redis caching, as I mentioned, right? Only we require not much, like one caching data that you need to keep it one key and store it there. So for kind of images, right? When you store it like branding images will be the images retrieved from the database or somewhere it will be more difficult. So that we store it there. Sometimes like country names will not be changed, right? So if you want to know the countries, no need to retrieve from the countries database table, whereas like it can store in caching, like states, districts. So while filling our the data, while registering the data, student it has to fill, right. While filling the address, first you after you name it will ask for to fill the state, right. When you select this, states will be populated. So all the states will be populated. When the states populated, as soon as you select the state like Telangana, so next column is districts will also be populated related to Telangana, right? So this will be not be required every time to get, because it will not keep on changing, right? It's static data. So that will be there, in caching there. And when I select Andhra Pradesh, on the Andhra Pradesh district will be so. So for caching a specific use case where their strengths are beneficial. This one. So they're DBMS. That's why like we need to choose RDBMS when and DBMS wisely based on our requirement. So this is about understanding of high level and database and RDBMS and DBMS and RDBMS, guys. I hope you got an idea how what is the database and how RDBMS and how to DBMS. If you already knew it, like it may be giving some kind of a fresh up again for you guys. But if you are new to this, like this is just you can save it somewhere. This I'm going to go to share this document in the group. Just you can keep it in our notebooks. Not notebooks are like a room or something, like probably just you can see it. It is for a few days, so that like you'll understand, and these words will be there in your mind. Okay. I think that's all I today for. I think we are taking more than 30 around 40 minutes, almost 1 hour we are coming to. Now, yeah, any questions? feel free to post the queries or you can ask the queries. Okay, I'll strongly encourage the students. It should be a interactive session. Every session should not be like one way that I'm teaching that you are listening. No. So whenever like we do have some kind of a my class, right, we do have between some kind of a pause and get some kind of queries and understanding exchange, because I want to make sure that you guys are getting it right. So yeah, feel free to post your queries or suggestions or anything like, and I can clarify whenever I find time.
Okay, sir.
It's great. I think that's all for today class. Yeah, tomorrow just let's get on to it. The next topic is one, yeah, one more, one thing that structured query language where we need to choose it, right? The RDBMS, the RDBMS that we are going to, choose MySQL as this is open source, because most of the students they are like can easily download and install and start using it. Let's get started tomorrow then. All right. Have a nice day. Thank you. Bye.